Hi friends, welcome to all. In this video we are going to see the lab activity configuring rapid PVST plus PortFast and BPDU guide. Here we can see our topology, also addressing table and VLAN assignments. We will go through the objectives of this lab activity. In part 1, build the network and configure basic device settings. In part 2, configure VLANs, native VLANs and trunks. In part 3, configure the root bridge and examine PVST plus convergence. In part 4, configure rapid PVST plus, PortFast, BPDU guide and examine convergence. We will go through the background. The per VLAN spanning tree, that is PVST protocol, is a Cisco proprietary. Cisco switches default to PVST. Rapid PVST plus, that is IEEE 802.1W, is an enhanced version of PVST plus and allows for faster spanning tree calculations and convergence in response to layer 2 topology changes. Rapid PVST plus defines 3 port states, that is discarding, learning and forwarding, and provides multiple enhancements to optimize network performance. In this lab we will configure the primary and secondary root bridge, examine PVST plus convergence, configure rapid PVST plus and compare its convergence to PVST plus. In addition, we will configure edge ports to transition immediately to a forwarding state using PortFast and prevent the edge ports from forwarding BPDUs using BPDU guard. This is what we are going to do in this lab activity. We can see the required resources, 3 switches, 2960, then 2 PCs, also cables. Coming to part 1, build the network and configure basic device settings. In part 1, you will set up the network topology and configure basic settings such as the interface IP addresses, device access and passwords. Coming to step 1, cable the network as shown in the topology. So first of all, we will build and connect this topology as they given in this lab activity to this Cisco packet tracer. Here we required 3 switches, 2960, also 2 PCs, and we will rename these devices. This is S1, S2 and S3. Also here we have PCA, and this is a PCC. Now we will connect these devices. Same device, here we will use a copper crossover, fast Ethernet 0/3 to fast Ethernet 0/3, fast Ethernet 0/1, fast Ethernet 0/1, fast Ethernet 0/3, fast Ethernet 0/1, then fast Ethernet 0/6 to this PCA, fast Ethernet 0/18 to this PCC. We will label these interfaces. This is a fast Ethernet 0/3. Here we have same fast Ethernet 0/3. Also here we have a fast Ethernet 0/3. Here we have a fast Ethernet 0/1. And this is a fast Ethernet 0/1, and this is also fast Ethernet 0/1. This is a fast Ethernet 0/6, and here we have a fast Ethernet 0/18. Also all these links we had to configure as a trunk. This is also trunk. and this link also trunk. Also we will highlight VLANs. Also we will label here, this is a VLAN 10 user. This is also VLAN 10 user. Coming to step 2, configure PC hosts. So here we can see the IP address of PCA and PCC, 192.168.0.2 and 0.3. Also we can see the subnet to mask. We will copy this address. Coming to PCA, desktop IP configuration. Here is the IP address. Coming to PCC, desktop IP configuration 0.3. Coming to step 3, initialize and reload the switches as necessary. Okay. Coming to step 4, configure basic settings for each switch. Disable DNS lookup, configure the device name as shown in the topology, assign Cisco as the console and VTY passwords, and enable login. Assign class as the encrypted privileged exit mode password. Configure logging synchronous to prevent console messages from interrupting command entry. Shut down all switch ports, then copy the running configuration to startup configuration. We will do these basic settings on these switches now. First of all, we will do it on S1. Enable configure terminal, host name as S1, no IP domain lookup. Also we will enable secret as class. Now we will go to line VTY 0 to 15 and we will set the password as Cisco. Login. Now we will go to a line console 0, password as Cisco. Login, logging synchronous, and now we will shut down all switch ports in this S1. So we will check the interfaces, do show IP interface brief, and here we can see all the interfaces from fast Ethernet 0/1 till 24. Also we can see 2 gigabit Ethernet 0/1 and 0/2. So we will go to these interfaces as a range, fast Ethernet 0/1 till 24. Also we have a gigabit Ethernet 0/1 and 2. We are going to shut down these ports. Copy running config, startup config. Now we will do it on S2. Enable configure terminal, host name as S2, no IP domain lookup. Also we will enable secret as class. Now we will go to line VTY 0 to 15, password as Cisco. Login. Now we'll go to line console 0, password as Cisco. Login, also logging synchronous. Now we will shut down all the ports in this switch S2. Interface range fast Ethernet 0/1 till 24. Also gigabit Ethernet 0/1 and 2. Shut down. Copy running config, startup config. Now we will do it on S3. Enable configure terminal host name as S3. Also we will enable secret as class. Now IP domain lookup. Now we will go to line VTY 0 to 15 and we will set the password as Cisco login. Also we will go to line console 0, password as Cisco login, also logging synchronous. Now we will disable all the shut down all switch ports. So interface or range fast Ethernet 0/1 till 24. Also gigabit Ethernet 0/1 and 2. Shut down. Copy running config, startup config. Now we will come to part 2. Configure VLANs, native VLAN and trunks. In part 2 we will create VLANs, assign switch ports to VLANs, configure trunk ports and change the native VLAN for all switches. Here they given a note. The required commands for part 2 are provided in appendix A. Test your knowledge by trying to configure the VLANs, native VLAN and trunks without referring to the appendix. Right. Anyways, here coming to step 1, create VLANs. Use the appropriate commands to create VLAN 10 and 99 on all of the switches. Name VLAN 10 as user and VLAN 99 as management. We will create these VLANs on these switches. First of all, we will do it on S1. Password is Cisco. Enable password is class. Configure terminal VLAN 10. Name as a user. Also VLAN 99. Name as management. Coming to the switch S2, configure terminal VLAN 10, name as user, also VLAN 99, name as management. Now we will come to the switch S3. Configure terminal VLAN 10, name as user, also VLAN 99, name as management. Coming to step 2, enable user ports in access mode and assign VLANs. For S1 fast Ethernet 0/6 and S3 fast Ethernet 0/18. Here we can see those interfaces, fast Ethernet 0/6 and fast Ethernet 0/18. Right. Enable the ports, configure them as access ports and assign them to VLAN 10. We will do that. First of all, we will do it on the switch S1. Cisco. Enable password as class. Configure terminal. We have to go to that interface, fast Ethernet 0/6, and we will give a no shut command. Also switch port mode as access. Switch port access VLAN 10. Now we will go to S3. CLI password class configure terminal. We will go to the interface, fast Ethernet 0/18, no shut, switch port mode as access, switch port access VLAN 10. Coming to step 3, configure trunk ports and assign to native VLAN 99 for ports fast Ethernet 0/1 and 0/3 on all switches. Enable the ports, configure them as trunk ports and assign them to native VLAN 99. Coming to our topology, here we can see those ports first, third, and 0/1 and 0/3 on all these three switches S1, S2, and S3. We will do it on S1 first. Configure terminal interface or range fast Ethernet 0/1, also fast Ethernet 0/3. No shut command. Switch port mode as a trunk. Switch port trunk native VLAN 99. Now we will go to S2 CLI. Password is class. Configure terminal interface or range fast Ethernet 0/1 and fast Ethernet 0/3. No shutdown. Also we will give switch port mode as a trunk. Switch port trunk native VLAN 99. Now we will come to S3. Configure terminal interface range fast Ethernet 0/1 and fast Ethernet 0/3. No shut. Switch port mode as a trunk. Switch port trunk native VLAN 99. We can see here, right. Now we will come to step 4. Configure the management interface on all three switches. Using the addressing table, configure the management interface on all switches with the appropriate IP address. So here we can see each switch IP address in this addressing table. So we will configure according to this addressing table. First of all, we will do it on S1. Configure terminal interface VLAN 99. Now we are going to set the IP address 192.168.1.11. Also the subnet mask 255.255.255.0. Now we will come to S2. Configure terminal interface VLAN 99. IP address 192.168.1.12 and the subnet mask 255.255.255.0. Coming to S3. Configure terminal interface VLAN 99. IP address 192.168.1.13 and the subnet mask 255.255.255.0. Coming to step 5, verify configurations and connectivity. Use the show VLAN brief command on all switches to verify that all VLANs are registered in the VLAN table and that the correct ports are assigned. We will check that. Coming to S1. Show VLAN brief, and here we can see those VLANs 10 and 99. Also the ports fast Ethernet 0/6 is assigned to VLAN 10. It's correct. Coming to S3. Show VLAN brief. Here we can see the VLANs 10 and 99. And the port fast Ethernet 0/18 is assigned to VLAN 10. And coming to S2. Show VLAN brief. Here we can see the VLANs we created 10 and 99. Next is use the show interface trunk command on all switches to verify trunk interfaces. Right, coming to S1. show interfaces trunk, and here we can see the trunking details. Fast Ethernet 0/1 and 0/3, trunking native VLAN 99. Coming to S2, show interfaces trunk, ports Fast Ethernet 0/1 and 0/3, it's trunking, and native VLAN 99. Coming to S3, show interfaces trunk, Fast Ethernet 0/1 and 0/3, trunking native VLAN 99, it's correct. Next is use the show running config command on all switches to verify all other configurations. Also, what is the default setting for spanning tree mode on Cisco switches? So we will verify that. Coming to S1, show running config, hostname, enable secret, and here we can see by default it's a spanning tree mode PVST. Also here we can see interface VLAN 99 and its IP address. Coming to S2, show running config, here also we can see spanning tree mode PVST. Also we will check VLAN 99 IP address, it's correct. Coming to S3, show running config, spanning tree mode PVST, and VLAN 99 IP address, it's correct. Next is verify connectivity between PCA and PCC. Was your ping successful? We will check that. First of all, we will get the IP address of PCC. Here is that 192.168.0.3. We will copy this address. Coming to PCA desktop command prompt, and here we are going to ping to that PC. Here is the IP address, and here we can see we are getting the replay. If your ping was unsuccessful, troubleshoot the configurations until the issue is resolved. Anyway, it's working here. It may be necessary to disable the PC firewall. Okay, anyway, we are not using the real PCs. So if you are using the real PCs, we have to check the firewall. We have to disable this PC firewall. Coming to part 3, configure the root bridge and examine PVST plus convergence. In part 3, we will determine the default route in the network, assign the primary and the secondary route, and use the debug command to examine convergence of PVST plus. The given a note, the required commands for part 3 are provided in Appendix A. Test your knowledge by trying to configure the root bridge without referring to the appendix. Right, we will do that. Coming to step 1, determine the current root bridge. Which command allows a user to determine the spanning tree status of a Cisco Catalyst switch for all VLANs? Obviously, we can use the command show spanning tree, or write the command in the space provided. Anyway, right? Use the command on all 3 switches to determine the answers to the following questions. There are 3 instances of the spanning tree on each switch. The default STP configuration on Cisco switches is PVST plus, which creates a separate spanning tree instance for each VLAN, VLAN 1 and any user configured VLANs. So what is the bridge priority of switch S1 for VLAN 1, S2 for VLAN 1 and S3 for VLAN 1? Right, we will see that using this show command, show spanning tree. Coming to S1, show spanning tree. Coming to VLAN 1, here we can see VLAN 1, and here we can see bridge ID priority 32769. Also here we can see the MAC address. Coming to S2, show spanning tree. Here we want to see only this VLAN 1. So better we will give a VLAN 1 here so that we can see the priority of VLAN 1. Here is that bridge ID priority 32769. Coming to S3, show spanning tree VLAN 1, and here we can see bridge ID priority of VLAN 1 on this S3 32769. Next is which switch is the root bridge, right? Anyway, we will check according to our topology. It may differ when you do yourself. We will check in S1 first, and oh, this switch is the root bridge. Here we can see this bridge is the root, that is S1, right? Right. Next is why was this switch elected as the root bridge? In our case, our root bridge is S1. Here we can see by default spanning tree elects the root bridge based on the lowest MAC address. So here we can see the MAC address of this switch S1. Here is that. So compared to other switches S2 and S3, S1 is having the lowest MAC address. So that's why it's elected as a root bridge. Coming to step 2, configure a primary and a secondary root bridge for all existing VLANs. Having a root bridge switch elected by MAC address may lead to a suboptimal configuration. In this lab, we will configure switch S2 as the root bridge and S1 as the secondary root bridge. Configure switch S2 to be in the primary root bridge for all existing VLANs. Write the command in the space provided. Here directly we will implement this command on the switch S2. Password, enable password class, configure terminal. Here we have to give spanning tree, then VLAN, and here we have to specify the VLANs. We have 1, 10, 99, and here we can see root. Configure switch as a root. Here we can see primary or secondary, so a specified primary. So this is the command that we have to give. Now we are going to press enter. Coming to B, configure switch S1 to be the secondary root bridge for all existing VLANs. Write the command in the space provided. Anyway, we will implement directly on this switch S1. Coming to S1, password Cisco, enable password is class, configure terminal. Here we are going to give a spanning tree VLAN, then we have to specify those VLANs 1, 10, 99. Also here we are going to give a root as a secondary. So this is the command that we have to give on the switch S1. Next is use the show spanning tree command to answer the following questions. What is the bridge priority of S1 for VLAN 1 and the bridge priority of S2 for VLAN 1? Which interface in this network is in a blocking state? Right, we will check that. First of all, coming to S1, show spanning tree VLAN 1, and here we can see the priority now. Bridge ID priority is 28673, and coming to S2, show spanning tree VLAN 1. Here we can see bridge ID priority 24577. Now we will identify which interface in the network is in a blocking state. By looking itself, we can identify this PortFast Ethernet 0/3 on the switch S3 is in a blocking state. We can confirm that using the show command. show spanning tree, and here we can see the interface fast ethernet 0/3 status is blocking on this S3. Now we will come to step 3, change the layer 2 topology and examine convergence. To examine PVST plus convergence, we will create a layer 2 topology change while using a debug command to monitor spanning tree events. So enter the debug spanning tree events command in privileged exit mode on switch S3. We are going to give this command debug spanning tree events. So spanning tree event debugging is on. Create a topology change by disabling interface fast ethernet 0/1 on S3. So here they are showing that output interface fast ethernet 0/1 they given shutdown, and we can see this listening, learning and forwarding. So before proceeding, use the debug output to verify that all VLANs on fast ethernet 0/3 have reached a forwarding state. Then use the command no debug spanning tree events to stop the debug output. Though which port states do each VLAN on fast ethernet 0/3 proceed during network convergence. So in this output itself we can see those listening, learning and forwarding. Anyway, we will try in our switches. We will try this debug spanning tree events command on our switch S3. Here we are going to give that debug spanning tree. Oops. Oh, it's an unrecognized command. So this debug spanning tree events is not supporting in packet tracer. It's supporting only IP and SW-VLAN. Anyway, so here they given the output for this debug spanning tree events. Next is using the timestamp from the first and last STP debug message, calculate the time to the nearest second that it took for the network to converge. Hint, the debug timestamp format is date, HH, MM, SS and the millisecond. Right, so coming to this output, here we can see it's 58:56 and here we can see it's 59:26. Here we can see the convergence time approximately 30 seconds. Now we will come to part 4, configure rapid PVST plus PortFast BPDU GAT and examine convergence. In part 4 we will configure rapid PVST plus on all switches. We will configure PortFast and BPDU GAT on all access ports and then use the debug command to examine rapid PVST plus convergence. They given a note here. The required commands for part 4 are provided in appendix A. Test your knowledge by trying to configure the rapid PVST plus PortFast and BPDU GAT without referring to the appendix. Right. So coming to step 1, configure rapid PVST plus. Configure S1 for rapid PVST plus. Write the command in the space provided. Anyway, we will implement directly on our switches. Here we are going to give this rapid PVST plus command on S1. So coming to the switch S1, configure terminal. Here we are going to give a spanning tree mode as rapid PVST. So this is the command what we have to use. Coming to B, configure S2 and S3 also for rapid PVST plus. So coming to S2, password Cisco, enable password class, configure terminal, spanning tree mode, rapid PVST. Coming to S3, configure terminal, spanning tree mode, rapid PVST. Right. Coming to C, verify configurations with the show running config, include a spanning tree mode command. Right. Coming to S1, show running config. We will try that. Include spanning tree mode. Here we can see a spanning tree mode rapid PVST, or simply we can give a show running config, and here we can see spanning tree mode rapid PVST. Now we will check it on S2. Here is that command, spanning tree mode rapid PVST. Coming to S3, spanning tree mode rapid PVST. Coming to step 2, configure PortFast and BPDU guard on access ports. PortFast is a feature of spanning tree that transitions a port immediately to a forwarding state as soon as it is turned on. This is useful in connecting hosts so that they can start communicating on the VLAN instantly rather than waiting on spanning tree. To prevent ports that are configured with PortFast from forwarding BPDUs, which could change the spanning tree topology, BPDU guard can be enabled. At the receipt of a BPDU, BPDU guard disables a port configured with PortFast. Configure interface fast Ethernet 0/6 on S1 with the PortFast. Write the command in the space provided. Anyway, we will implement it directly on the switch S1. Coming to the switch S1, here we are going to give that command. Configure terminal. We have to go to that interface which is connecting to our PC. That is interface fast Ethernet 0/6, and here we are going to give spanning tree PortFast. Coming to B, configure interface fast Ethernet 0/6 on S1 with the BPDU guard. Write the command in the space provided. Right, we are going to implement directly on S1. Here in this interface we have to give spanning tree BPDU guard enable. Coming to C, globally configure all non-trunking ports on switch S3 with the PortFast. Write the command in the space provided. Right, coming to S3, here we are going to give the command. We have to go to global configuration mode, configure terminal, and spanning tree PortFast default. Coming to D, globally configure all non-trunking PortFast ports on switch S3 with the BPDU guard. Write the command in the space provided. So coming to S3, here we are going to give spanning tree PortFast BPDU guard default. Invalid input detected at BPDU guard. I think this command is not supporting in this packet tracer. Anyways, now we will come to step 3. Examine rapid PVST plus convergence. Enter the debug spanning tree events command in privileged exec mode on switch S3. Create a topology change by enabling interface fast Ethernet 0/1 on switch S3. Here we can see that. Also we can see the output. Initializing port fast Ethernet 0/1. Here we can see transmitting an agreement on fast Ethernet 0/1 as a response to a proposal. Right. Using the timestamp from the first and last RSTP debug message, calculate the time that it took for the network to converge. If we observe the output, here we can see initializing port FA0/1. Here we can see the time 28:37. Right. So here we can see 28:37. It's almost under a second. 622588. We can see only the changes in milliseconds. Right. Now we will come to these reflection questions. What is the main benefit of using rapid PVST plus? Obviously, rapid PVST plus or decreases the time of layer 2 convergence significantly over PVST plus. Coming to the second question, how does configuring a port with the PortFast allow for a faster convergence? Here, PortFast allows for an access port to immediately transition into a forwarding state, which decreases layer 2 convergence time. And coming to the final question, what protection does BPDU guard provide? Obviously, BPDU guard protects the STP domain by disabling access ports that receive a BPDU. BPDUs can be used in a denial of service attack that changes a domain's root bridge and forces an STP recalculation. Well, here we can see appendixes, all the switch configurations. Anyways, we have done all these. Friends, so that's all in this lab activity, that is configuring rapid PVST plus, PortFast and BPDU guard. Friends, if you have any doubt in this lab activity, please comment below. Also, if you like my video, give a thumb and share to your friends. And don't forget to subscribe this channel so that you will get latest uploading video info directly into your Gmail. Thank you.